Arithmetic means, geometric means, and harmonic means between A and B. See, usually we will face two different situations in different problems or in groups. One thing is arithmetic means between A and B, or arithmetic mean of A and B. I am again repeating, arithmetic means between A and B, arithmetic mean of A and B. There is a slight difference between those two, right? See, now we are discussing about the arithmetic means between A and B. And in the next class, I may give you an idea related to the arithmetic mean of A and B. Now have a look at this, what we are discussing. We are discussing about the arithmetic means between A and B. See, the definition is very clear. For suppose, if, have a look at this, A and some numbers, x1, x2, x3 and so on, xn minus 1, comma xn, comma b. See, I have few terms, a, x1, x2, x3 and so on, xn minus 1, xn, comma b, right? See, or in, right, or in arithmetic progression, or maybe in geometric progression, or maybe in harmonic progression. What I am going to tell you, see, if they are in arithmetic progression, then we will announce that if they are in arithmetic progression, then x1, x2 and so on, xn, or n geometric means, no, arithmetic means, n arithmetic means between A and B. Or otherwise, if they are in geometric progression, then we will announce that x1, x2 and so on, xn, or n geometric means between A and B. In the similar manner, and these are mentioned as n harmonic means between A and B. See, my definition is to mention, see, few numbers as arithmetic means between A and B. So if you insert those numbers in between A and B, all together they will form a sequence. See, if that particular sequence is the arithmetic progression, then these inserted middle values, middle numbers are termed as the n arithmetic means between A and B, or if they are in GP, n geometric means between A and B. If the total sequence is forming an harmonic progression, then we will say these terms as n harmonic means between A and B. Once again, I am repeating you, n arithmetic means, n geometric means, and n harmonic means. That n also plays a very important role, right? See, there is there is no a fixed situation that, see, to insert n numbers between A and B. Sometimes we may insert only one number between A and B. Sometimes we will insert two numbers between A and B, where our n becomes 2. And sometimes our value of n is 3. And sometimes our value of n is 4, like that, right? So I will give you a few examples, and after that we will discuss again, right? See, once again I am repeating you, these numbers are mentioned as n arithmetic means, or n geometric means, or n harmonic means, depending upon the sequence, by considering that first and the last one, A and B together. If the total sequence is forming AP, n arithmetic means, forming GP, n geometric means, forming HP, n harmonic means. I will give you some examples, right? Just have a look at this. First, suppose you will face few situations, few problems related to this. For example, they will ask you like this, okay? Yeah, I will give you that. First, suppose insert 4 arithmetic means between, okay, what I have to say, 3 and then and 27. 3 and 27. So once again I am going to repeat. See, 3, I am just framing the problem, right? You may say it as 28, right? Insert 4 arithmetic means between 3 and 28. See how to insert 4 arithmetic means between 3 and 28. Why we need to insert only 4 arithmetic means between 3 and 28? We have many options, right? See, look at that. We have a chance to insert 2 arithmetic means between 3 and 28. We have a chance to insert 3 arithmetic means between 3 and 28. We have a chance to insert 4 arithmetic means. We have a chance to insert 400 arithmetic means also in between 3 and 28. Now my first thing is a simple problem that we need to insert 4 arithmetic means between 3 and 28. Right? Since we are going to insert 4 arithmetic means between 3 and 28, and I don't know those 4 arithmetic means, you just let them as x1, x2, x3, x4. If you are inserting 5, take one more like xy. If you are inserting 10, you just treat them as x1, x2, x3 and so on x10. Right? Since these x1, x2, x3, x4 are the 4 arithmetic means between this 3 and 28, then you may write it like this. How? 3, x1, x2, x3, x4, 28 are in arithmetic progression. Since the question is asking you to insert 4 arithmetic means, you are considering the total sequence is AP. If they ask you to insert geometric means, you may write all these things are forming in GP. Right? See, the question is about arithmetic means. You just take it as arithmetic progression. Since they are forming an arithmetic progression, look at this. For this arithmetic progression, this 3 is the first term. Is it right? And this x1 is the second term. This is third term, this is fourth term, this is fifth term, and this is what? Sixth term. Is it right? Since this is the sixth term, we may write it like a plus 5d, the sixth term of the arithmetic progression. So now T6 is 28 is equals to a, the first number is 3 plus 5 times of d. And now if you solve, you will get the d again 5. Since d is 5, the common difference of arithmetic progression is 5. So to get the next term, always you need to add for the 5 for the previous term. Now your first term is 3, right? Therefore, since your first term is 3, then for the second term what you need to do? You need to add 5. So 8, and then add 5, 13, and then 18, and then 23, and then add 5, 28. Now at the end, these 3 and 28 are the given numbers, and we have 4 more numbers in between those 3 and 28, such that they are forming an arithmetic progression. Now we will announce these 4 terms as the arithmetic means between 3 and 28. Have a look at this. Okay. First, suppose if they are asking you to insert only one arithmetic mean. Again, see another problem, right? Insert one arithmetic mean between 3 and 28. What you say? Since you are inserting only one arithmetic mean, you just let that one arithmetic mean as x. So 3x and 28 are in arithmetic progression. Since you are inserting only one arithmetic mean, you will say these 3 are in arithmetic progression. Since those 3 are in arithmetic progression, 2 times of the middle one is equals to first one plus last one. And our value of x is equals to 31 by 2. At the end we will conclude that this 3, this 31 by 2 and 28, these all together will form an arithmetic progression. Right? Right? See, since I just framed the problem like that to make the d as 5, such that this is somewhat simple one. Or otherwise you may get fractions also. Right? So, for example, if anybody asks you to insert 7 arithmetic means between 3 and 28. See, since they are asking you to insert 7 arithmetic means, you just insert x1, x2, x3, x4, x5, x6, x7. Right? And then the final sequence is in arithmetic progression. Again, find common difference in such manner and then list out all the terms. Right? And for suppose if they are asking you to insert for geometric means, then you need to take here as geometric progression, and instead of a plus 5d, if it is geometric progression, you need to use a into r to the power of 5, the sixth term of the GP, and then find common ratio. From there it is very clear, right? So this is a small discussion related to the arithmetic mean, geometric mean and the harmonic mean. Have a look and go for a screenshot.